We're now going to look at the single node pair circuit. So just as we have had the single loop circuit, where all the elements were in one loop sharing the common current, I, we now have the single node pair circuit where all elements are in parallel, and so they share the same voltage. Okay, elements share the same voltage. So the single node pair circuit has one unknown, and that is the differential voltage, the voltage across the elements, the voltage that is common to all of them. So if one node is designated as a reference node, having zero potential, then the voltage of the other node becomes the only unknown voltage to be solved for. So recall, we can only define the voltage at a node relative to another node. So really what we're solving for here is we're solving for the branch voltage, if you will, which is common to all the elements, or we can say we're solving for this node voltage where the reference voltage is the lower node here. So to solve for the voltage, we write a KCL for either node. Typically we'll write it for the non-ground reference node, but you could do it for either node. And then using KCL and the VI or constituent relationship for each element, primarily resistors at this point, one can write the KCL equation in terms of one unknown, the voltage, V. Now knowing V along with the VI relationship for each element then allows us to calculate the current or the power. So for instance, if I have a 10K resistor here and I find that V is equal to 1 volt, then I can calculate that the current flowing through this 10K resistor is just 1 over 10K or 0.1 milliamps, and I can also compute the power. And lastly, we want to point out that many circuits can be reduced or simplified to an equivalent one node pair circuit, even though they're not initially a single node pair circuit, just as we saw for the single loop circuits.